Hello everyone, welcome back to my class and to my channel as well. So in our today's class, let us study about a very interesting and important chapter, that is electric charges and fields, and which is your first chapter of your second PUC, where it carries a maximum marks of total 11, and this 11 marks is further divided as 1 plus 2 plus 3 plus 5. So you will be getting 1 mark question and one of 2 mark and one question of 3 mark and one question of 5 mark you'll be getting. So in the 5 mark question you may get a theory based or numerical problems you may get. So it is very important to study well and get thorough with every concepts of this chapter. Now going to study about the concepts of electric charges and fields. Let us first study what is a charge, and let us also know, after knowing the concept of a charge, what is electrostatics. So now firstly let us know what is charge, and then again let us come back to this slide. Let us know what is electrostatics again. Now, if I consider electric charges, it tells you that it is a fundamental property possessed by the objects or particles that makes it possible for them to exert electrical forces. So it will respond, they say. So what is it? Let us know what is the meaning of this definition. So it tells you that fundamental property possessed by the object or particles. Now, if I consider myself, I have got certain characteristics. In the same way, if I consider tiny particles, that is, you are in your atom, you might have got a electron, proton, neutron. So your electron, this is electron is a particle which has got a charge on them. So it is a fundamental property possessed by the particle. So if I consider your electron, it has got a charge on it because it exerts electrical forces. So it has got negative charge. And if I consider a proton in the atom, in the nucleus, it has got a positive charge. Yes, positive and negative charge, as you can see here. So these are the charges possessed by the particles. So positive and a negative charge attracts each other, and that is why you can see that the arrow mark is in this way. And if I consider the like charges like negative negative, these two repel each other, and that is why you can see that the arrow mark is in this way. Yes, so this is something called as electric charge. So hope I have made it very clear to you what is electric charge. Yes, and there are two types of charges, that is something called as positive and a negative charge. Now coming back to the previous slide, you can see that there is a concept, that is something called as electrostatics, which tells you it is a branch of physics again. So physics has got many sorts of branches. So in that, electrostatics is one, and where you will be dealing with the study of charges. Hope you understood what is a charge, and now you're studying the charge at rest. So why at rest only will study? So if I consider myself again as an example, if I start running, can you make me out? Can you figure me out how I am? No. So only if I am at rest you can see me, you can observe how the person looks, how the person is. Yes, in the same way, if I consider the study of charges at rest, I can completely study about the charge. That is why we are going to study the charge at rest, and that is something called as electrostatics. Hope I have made it very clear to you what is charge and what is electrostatics. Now, going to another concept, that is something called as electrification. So it tells you that, just reading the definition, it is a process of adding or removing of charges from a body. So what is it? You are adding or removing a charge from a body. See children, so one thing you should understand, what kind of charge you are adding and removing. That too in the concept of electrostatics. That is, electrons you are going to add and remove. Okay, that is something called as electrification. And one more thing you should understand, we are never going to consider proton over here. So just we are going to play with the electron. So you are removing or adding an electron, and that is something called as electrification. Now, it tells you that positively charged and negatively charged, when will you call a substance or a object or a particle to be as a positively charged and negatively charged? So let us learn now. So if I consider positively charged, it tells you that how shortage of electrons or removal of electrons is something called as positively charged. Now, how do you say it is positively charged? Now, if I consider this atom has got three electrons. Yes, one, two, three. And how many number of protons over here? One, two, three again. Now, I just want to know, what is this positively charged? So what are they telling you? It is the removal of electrons. So just remove one electron and imagine for yourself, as this is your PPT presentation. You have to imagine to know the concept very well. And now I remove one electron, and how many electrons are remaining? Only two electrons. And tell me now, how many protons? You are not going to remove any of the protons, and it is not so easy to remove a proton. So you have got three proton, but what is the number of electrons over here when you take out one? It is two electrons. So which is bigger? So proton, number of proton is more, and that is why they say that shortage or removal of electron is something called as positively charged. Now, going to negatively charged, it tells you that excess of electrons or adding electrons. See children, so excess, more number of electrons. So in an atom, what do? I add one electron. Imagine again, one electron I'm going to add, and so there are total three. One more I'm going to add, four electrons. And now what is the number of proton? It is three. So four is more or three is more? Four is more, right? So four electrons are there. So negative charges in an atom are more, and that is why you call it as negatively charged. I hope that I made it very clear to you what is electrification. So even though we consider this proton over here to see that whether the atom is positively charged or negatively charged, but we are never going to use the word particularly as proton, because this is your electrostatic concept and we are going to deal only with your electrons. So removal or adding of an electron to a body is something called as electrification. So this is very simple. You have to imagine, that's it. Next, going to another concept, that is something called as conductors and insulators. See, in your last chapter, that is your semiconductor, in depth we'll be studying about what is a conductor or an insulator. Now just let us know uh, what is the meaning of it. That's it. Now if I consider conductors first, then let us go to an insulator. So now if I consider a conductor, it says that substances which allow readily a passage of charges. One thing, conductors is something that metals, yes, say for example aluminium, copper, gold, silver, so these are your conductors. Okay, so if I consider a vessel, a big vessel, what do you find there? So aluminium, so you'll be having many of aluminium atoms over there, many atoms. So in the same way, if I consider this wire, Yes, these are the electrical wires you find in your homes also. So in these wires, this I have enlarged it and shown you in this image, that it tells you that this copper wire is made up of tiny atoms. So round thing you can find over there, is it? So there are many millions of atoms in just one wire. So what am I telling you is, conductor is something that which allows readily a passage of charges through them. So charges means immediately it should come into your mind that it might be electron. In what concept? Electrostatic concept. So now if I consider the conductors, it tells you that the passage of charges through them is something called as conductors. So yes, there is a passage of charges, that is your electrons can flow from one atom to another atom. Yes, one atom has got proton, electron. So in the same way, your electrons can move from one atom to another atom, and the flow of these charges, the flow of electron, is something called as electricity. So electricity is produced, electrical energy is produced. Due to this electrical energy, you can see that your appliances like light, your bulbs, your fans, your mixer grinders can function so easily, it can work, is it? So that is something called as conductors. Hope I made it very clear to you. And you can find your conductors are having a set of completely detached electrons from their atoms. These are called a free electron. Yes, I told you, electron starts to flow from one atom to another atom. This is something called as conductors. Next, going to an insulator. So it is dead opposite to this conductor, and it tells you that the charges are not allowed to flow through them. Yes, substances which do not allow charges through them are called as insulators. So I can say, for example, wood, glass, plastics. So these are the insulators. And do you find in any of the electrical appliances you'll use any wood or plastic or glasses? Never. You're going to use conductors, metals you're going to use, that is aluminium, coppers, gold, silvers, these kind of you're going to use as a conductor. So hope I made this concept also very clear to you. And next, going to another concept, and that concept is something called as earthing. What is it? Grounding or earthing. So it tells you that in your home, if you observe, just go around your home and you can see one wire which is connected to the ground, to the earth. And why is it? Because of, so many of the charges, that is your electrons, flow through the wires around your home. So many electrical appliances, for the appliances you might find the connecting wires in your home, and there you can find that, as I told you, a wire is made up of some conductor, copper wire, and in that copper wire you have got millions and trillions of atoms. In those atoms you have got electrons, where electrons can move as it is a conductor. So as your electron starts to move, say in case if the electrons are very much more, it may destroy your appliances like washing machine, bulbs, fans. It may destroy these appliances. And how to avoid these things? How to avoid the overflow of these charges? It is by giving the connection to the earth. So you're giving the connection like this way. Hope I have convinced you in this concept, that yes, we gave a connection to the earth, and that is how you can see that the overflow of the charges or extra charges flow into the ground, and this is something called as earthing or grounding. So hope I have made this clear to you. And next, going to another concept. That concept is something called as point charge. So as I told you, a point charge means if size of a charged object is very small, say like electron or a proton, then we treat them as a point charge. Now, as I told you, giving a few examples, if I consider a aluminium vessel, so that big vessel has got millions and trillions of atoms, aluminium atoms it has got, and for that you're going to tell as whole charges of object. So what is it? Whole charges of object. Say if the size of the object is very small, then we treat that as a point charge. So charges on that particle is something called as point charge. That's it. Next, going to another concept, properties of charges. So what is it called as? Properties of charges. So now the first property of a charge is something called as additive. What is it? It is called as additive. So now what is it? It tells you charges gets added algebraically. You understanding? Now in case if there is a big metal, okay, metal plate, your metal plate has got many charges over there, many atoms. In that atom you might have got many electrons. Yes, it might be positively charged or negatively charged. So how do you consider it is a positively charged or a negatively charged? By the concepts of electrification, removal or adding of electrons. So now what is that I'm telling you? So many, if I consider metal plate, in that many atoms will be there and their charges would be different. So now the charges might be plus q, another atom's charge would be minus q, another would be plus q3, in that way. So how these are combined? If these are combined, we get algebraically, we are going to add it. How we are going to add it? q1 minus q2 plus q3 plus q4 minus q5, in this way. So if I take a pictorial representation, this, if I consider this yellow color one, I would consider that to be as a bowl of copper bowl. Okay, so this has got many charges. That is something called as q1, q2, q3 charges I have got. And just think, it is all positively charged, and these tiny charges are adding up, q1, q2, q3 it is going to add, and finally what is the result you would get after adding that algebraically? Something called as capital Q. So hope I made it very clear to you. So in a vessel, many tiny charges will be there. You're going to add it algebraically and you would get a net charge after adding it algebraically. Hope I made this very clear. This concept, this is the first property of a charge. Next, going to the second property, this is something called as charges are conserved. So conserve in something that you might have studied in your very lower classes, the conservation of energy. So you cannot create it, you cannot destroy it. Yes, but in the same way, charges also cannot be created by human being or destroyed, but only you can find somewhere here, sometimes nature creates or destroys a charged particle. So this is something called as the second property of the charge. So there is one example also for you. So example, neutrons changes into proton and an electron. So your neutrons are changing into proton and an electron. And you can see in this equation neutrons are neutral charges. It now you can find a proton and a neutron. So E plus E minus. So proton E plus E minus, both have been cancelled each other, and right hand of the equation is positively charged. Sorry, it is neutral, and here on your left hand side of the equation you can find there is a neutral particle. So on your right hand side also it is neutral by cancelling out its charges, and your left hand side is also neutral, and you can find that the charges are conserved wherever it goes, wherever it changes, as your neutrons changes to proton and an electron. In the same way, when there is some changes occurring in the particles, yes, there is a conservation of charges, it will satisfy. Now, this is your second property. Next, going to the third property, which is a very important property, and you will be getting a definite question in your examination. And it is not just because of your examination purpose. I'm telling you, I just want you to understand what is a concept. So now if I consider the third property, it tells you about the quantization of charges. So what is that quantization? Just with the simple explanation, I just like to tell you, an atom consists of a proton, neutron and an electron. What? An atom consists of a proton and a neutron in between, and an electron which is revolving around that. Is it? Now, as we are talking about the concepts of electrostatics, we'll be dealing with the electrons alone. So if I consider the electrons move from one atom to another atom. Yes, I had told you a copper wire has got many electron atoms, and those atoms have got charges in them, electrons, many electrons are there. Now what will happen when the electrons have the tendency to move from one atom to another atom? You can find that the charge, that is your electron whole, the whole electron starts to move, and it is not splitting into different parts in this. In the sense, I'm just telling you that electrons cannot be divided furthermore. Electron is the final particle, so you cannot divide it. So you can see that, say for example, if I consider an atom, that was a tiny thing we had believed, but now atom has got proton, neutron, electron. Is it? So now if I consider the electron is not going to be divided anymore. That is the final particle. So quantization tells you that all particles, all the charges are integral multiple. So what is it? It is an integral multiple of a basic unit of charge denoted by E. So n tells you about the number of electrons. So in this equation you can find that n tells you about the number of electrons, and here E tells you about the charge that the electron carries. And the value of E, the charge, is something that E is equals to 1.6 into 10 to the power of minus 19 coulomb. And coulomb is the SI unit of a charge. So now, and if I consider Q is equals to N into E, it tells you about the quantization of charge, the net charge on a object, on a particle, and this is something called as quantization of charges. Now again explaining, or again a recap of this concept, just because it is a very important one. Quantization of a charge is something that it is an integral multiple. Okay, so you're not going to get any of the uh, fractions. So 1 by 2, 2 by 3, these kind of things you're not getting, because your electrons are whole numbers you're going to get, but never as half quarter? No. So it is an integral multiple, and the value, the charge q is equals to n into e, where n is the number of charges what you're going to consider. So it tells you that basic unit e is equal to the charge on the proton or electron. So as we are, so you can see that proton or electron. So if I consider the electron, so we are dealing with the electrostatics, and I'm going to consider electron over here first. So now there is a unit of the charge. What is charge? It is a fundamental property of the object. So SI unit of a charge is coulomb, and the value of E is 1.6 into 10 to the power of minus 19 coulomb. So hope I have made it very clear to you. Next, going to another concept. So these are the three property of charges which is very important. You may get for 3 marks, you may get for 1 marks. So 3 marks is for, they may ask you to mention the properties of charges, or they may ask for 1 marks what is quantization of charges. They may also ask you for 2 marks telling you that define what is quantization of charge and give the formula for that. So this is all about. And next, going to another concept, Coulomb's law. So this is a very important concept, and you will get this concept for 3 marks, and you have to write the definition of this one with the diagram, and the formula also you have to write. So if they ask the value of the forces, and that also you will be uh, supposed to write in your examination. Now if I consider Coulomb's law, it tells you that, so I'm not going to read the definition here. I just want to tell you it is directly proportional. What is directly proportional, children? So if I consider the Coulomb's law, we are going to find the value of a force. But what force between what? Two charges. Clear? So if I have got two charges which is positively charged, two are positively charged. So as this is positively charged, they exert certain forces on each other. So what kind of force? Positive, positive, repulsive forces you would get, and that is why your arrow marks are on other side. So force is directly proportional to the product of the two charges q1 and q2, and inversely proportional to the square of the distance between them. So the distance between the two charges is something that r, and through the calculation part I'll just make another video how is this a square of the distance you would get. Though the distances are, you're going to take that as a square of the distance, and in my next video I'll put the link over this video of another video which I'll be telling you about the square of the distance between the two objects or the two particles, and in that video you might be even more clear about what are the other concepts which is connected to this concept, that is the Coulomb's law and the square of the distance between them. Now, just knowing what is a Coulomb's law, it tells you the force is directly proportional to the two charges, that is product of the strength of charges, and inversely proportional to the square of the distance between them. So this is all about. And going to the expression of the Coulomb's law, it is given as F, yes, directly proportional to Q1 Q2 divided by R square. And now if I take out this proportionality constant, what I have to add, or what I have to introduce a constant that is called as K, and that K is something called as arbitrary probability constant, and K depends on the medium in which charges are placed. Which medium? What kind of mediums we have kept the two charges in, and it depends upon these mediums also. And later on, r is a vector in the direction of forces, and its magnitude is equal to t between the two charges. So now, as I told you, this is the value of forces you would get. And F is equals to K Q1 Q2 divided by R square, and K is a constant. And knowing the value of K, you can see that K is 1 divided by 4 pi epsilon naught. What is it? The value is given by 1 divided by 4 pi epsilon naught, and this epsilon naught is called as absolute permittivity. So in which medium you are going to keep two charges, and this absolute permittivity depends upon that. So if it is a free space, if I keep it in the vacuum, the value of epsilon naught will be equal to 8.8 into 10 to the 8.854 into 10 to the power of minus 12 um, per Newton meter square into Coulomb square. And the value of 1 divided by 4 pi epsilon naught, the value of k, the value of k value is equals to 9 into 10 to the power of 9 Newton meter square per Coulomb square. So this is all about today. So we have studied about what is a charge, what is electrostatics, and what is conductors, insulators, what is earthing. And not only that, we understood what is the property of the charges, and finally we studied what is a Coulomb's law. And not only that, Coulomb's law is very easy, that you have studied in your gravitation chapter of your first PUC. It is same thing. You're going to remove the masses m1 m2 and just replace charges q1 q2 in your Coulomb's law. That's all. It is very easy. But what is the thing? You have to by heart the values of these constant, that is epsilon naught, k value, the constant value, so that it will be very much useful for you when you just try to solve your numerical problems. So this is all about today. Let us see in the next class. Thank you. And if you like the video, do not forget to subscribe my channel. And this is a very informative, I would be giving you, though it is your representation like PDF PPT representation I'm giving you. uh, you will just have to think more and more, imagine more, that's it, and nothing else. And this is not time waste. And yes, I have made it very much informative to you. Hope I have cleared all your doubts, and I will meet you in the next video, upcoming video, and it will be uploading very soon. And thank you. Bye bye.